As of now, we have two forms. We have the y equals ax squared plus bx plus c, and then the y equals a x minus h quantity squared plus k. Thank you. Those are the two forms we have as far as the quadratic equations are concerned. We also have the intercept form, the p and q one, but I don't think we'll get too much of that right off the bat. We'll write that one out also. Excuse me. The other one was the y equals a x minus p x minus q, where the p and q stood for your zeros of where the x-intercepts and stuff were. Last year we called them standard form, vertex form, and intercept form. This book doesn't call this anything, I really don't think, but it calls what we were calling vertex form standard. So it's kind of weird how they do that. They call this the quadratic function. They call the second one the standard form, and then this one I believe is still intercept form. I don't believe they even defined that in this unit, but I know we'll use it because it's pretty easy. What's up, buddy? What's up? Thanks, you're the best. I know. Thanks for looking out for me. Get a bigger truck.
You know what? It's not.
That thing even have 3 cylinders that works?
It's got 4 and they all work.
Oh, okay. Just wondering.
Actually, it's got 6 and they all work. So.
I didn't know you can count that out. See ya. What's that? Get me something. What? I'm not sure. So here we go. We're going to talk about writing the standard form of the equation of a parabola whose vertex is at 1, 2, and it passes through the point 0, 0. This is where it's going to be that vertex form, because you've got a vertex and a point. So when I talk about the standard form, we're looking at the y equals a x minus h quantity squared plus k. No, we didn't need any. I didn't want you guys to have graph paper. I don't think you really need it. All right. And those of you guys that had it before, I mean, we rarely use graph paper, right? I mean, even with conics, I didn't like to use it because I wanted you to count it. Anyway, what did h and k stand for in this case? The vertex. H and k are your vertex. So if you have the vertex at 1 and 2, and it goes through the point 0, 0, if this is your h and this is your k, what's the 0 and 0 standing for? The x and the y. So according to my math skills, we have 1, little 2, little 3, little variables, 4, 5 total variables. And I know 4 of them. Which one am I solving for? Hey! It's Fonzie. Do you know who Fonzie is?
No.
Happy Days?
I know who he is.
No. Never.
I know.
Fonzie wrote a triumph, in case you were wondering. Fill in the blanks. 0 is a 0 minus 1 quantity squared plus 2. And what we're doing here is we're going to solve for a, and then just rewrite the equation in terms of your a, h, and k. And that's really all there is to this. Okay? So let's see if we can figure this out. What's 0 minus 1?
Negative 1.
What's negative 1 squared?
1.
1. So we have 0 equals 1a plus 2. Yeah. Move the 2, what do you do?
Subtract.
Subtract it. So what's a? A is negative 2. What we're doing here is we're having to solve for the value of a. What is that multiplier, if you will? You knew your h and k was already at 1 and 2, so you have your a and your h and k. So you just fill in the blanks then. Y equals negative 2 x minus 1 quantity squared plus 2. And there's your answer. I know you did that last year. They just said write it in terms of in vertex form as opposed to what they call standard form. That's it. Okay? It's just solving for A. Oh yeah, absolutely. I was going to grab another example. And try to stand out of your way. Did you guys, any of you guys in the regular algebra classes, the algebra 2 class, do the standard form, your ax squared form, with 3 points as a system of equations?
I feel like we do, but I don't find it.
Did you do it with the system or did you guys do it with the matrix? We do it with matrix. I don't know, it doesn't really show up. I was just curious if you guys did that because I thought it was another good extension. Yeah.
No, I know.
Okay.
I'm talking about the first, that top part.
Yeah.
One is.
0 minus 1 is -1. -1 squared is 1.
Oh, shoot, I didn't say square.
It wasn't all the way up there.
Yeah.
That's fine.
Okay.
All right. Let's look at another one.
Left.
Ooh, interpreting from a graph. Scary. So we have 2 ordered pairs there. We have 0, 1 and 1, 0. Which one is your vertex?
1, 0.
1, 0. So if 1, 0 is your vertex, what's your h and k?
H is X minus
What's your h value in this?
1.
1. And what's your k? Yes, sir.
How do you know which one is the coordinate? Like if you're looking at the graph, like how do you know which one is the
There's your vertex. Your vertex is hk. For the parabolas, your vertex will be h and k.
So it'll be the bottom of it.
Or the top of it, whatever the point of that. It'll be given to you like that. All right. Your vertex will be is where your h and k lie. So then you have your point at 0 and 1. So once again, you know 4 of the 5 variables. It's just a matter of substituting in and solving for A. So 1 is A, 0 minus 1, quantity squared, plus 0. What's 0 minus 1? What's -1 squared? 1. What's A? 1. Then I can write my equation out. Y equals 1, x minus 1, quantity squared plus 0, or y equals x minus 1, quantity squared. Means the exact same thing.
That's the answer.
That's it. That's all it is. That's all that is. It's being able to just identify what h and k is, what's your x and y, and basically you're solving a 2-step equation there. That's it. The only thing that you guys will screw up is that you're going to type in your calculator -3 squared, it's going to say -9. You'll do something stupid like that. Don't do that. Think. What? You're doing all. Let's try and make it difficult. My vertex is at 512, and the point is at 715. write it out. My h and k in this case would be 5 and 12. The x and y in this case are 7 and 15. So 15 has to equal a. 7 minus 5, quantity squared, 12. So let's see, we get 7 minus 5 is 2. 2 squared is 4. So 15 equals 4a plus 12.
Take 12 away,
Take 12 away.
you'll get 3/4 equals A.
Very good. And there's your value of a. And then you just resubstitute back in. Y equals 3/4 x minus 5, quantity squared, plus 12. Do you guys vaguely remember this from last year? Good. The other part that I kind of want to just briefly touch on is when you're working with quadratic style word problems, what does it actually mean as far as what you're reading? For example, if you remember last year, there was a problem in the Alpha 2 book that talked about the cannon. The cannon shot, and it landed all the way out there. And it gave you some model. And you were able to figure out from that model how far it was going to shoot and all that kind of stuff. Just by looking at that parabola, not knowing anything else, is it going to be a negative or a positive x squared? Why is it negative?
It's down like a frown.
It's down at the front, okay? So we know this has to be a negative x squared something. What would this point be called? It's the vertex, but it's also called the what? It's the maximum, okay? This was the maximum. Now, let's just say, for argument's sake, that this value started at 0. It started at 0. If I'm looking at the function itself, would there be a value of c? Think about what the value of c would have to be if I'm starting at the origin. Go ahead, Martin. You got it. Martin. It's 0. The value of c, like Mr. Martin said, would have to be 0. This value of c in a quadratic equation is always your y-intercept. Okay? Because if you substitute in 0 for x, you'll have x squared plus some x plus some constant here. If it's 0 plus 0, it's going to be whatever this is. There was another problem I think we did last year about an astronaut throwing something. It threw from 6 feet, so it was plus 6. So it meant the graph started 6 feet up in the air. There was a word problem in the Alpha 2 book, if you remember, the shot put. Started at like 5 feet in the air and she shot putted. You vaguely remember? It's the basic idea here. This value of c represents where it's starting. So if it starts at 0 and it spans all the way over here, this value, like Devin said, is the maximum. It's the vertex. Wouldn't that also be the halfway point? Now, think about what your ordered pairs give you in terms of a graph. Your ordered pairs go x and y, right? So this would be some maximum value at x comma y, where x is your horizontal distance, y is your height. How high up does it reach? If you found this maximum value, what would you do to it, the x-coordinate, to figure out where it landed? Double it. Very good. And the reason that it works for a problem like this is because this is symmetrical. It would fold in on itself because it starts at 0. It's a nice little trick to remember those little bits of a quadratic if you're starting at 0. If you're not starting at 0, it might not work. Okay? If you're starting at 6, you'd have to look in your table to figure out where it's crossing through. Okay? It's very, very easy to do. I'm trying to think if I had to do a problem. Let's look at this. For example, what I want to do is kind of read through this with you guys just to draw what in the world is this asking me to be able to do. It says you have a baseball is being hit at the point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees with respect to the ground. The path of the baseball is given by the function blah, 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 blah. You don't have to come up with a model. It's going to tell you some equation. Okay? Where f of x is the height of the baseball, the y value. F of x is synonymous with y. And x is the horizontal distance from home plate in feet. What is the maximum height reached by the baseball? Visually, where does this graph start? At 3 feet up. At time of 0, or feet of 0, it does this. It goes up and lands out here. Unless you're Schwarberg, then it lands up on top of the scoreboard. They found that on the scoreboard.
Oh, really?
You know that?
I thought it went over.
Everybody thought it went over. They actually found it, somebody found it that night because there was a guy out in the right field corner, had a picture of the scoreboard when they were doing the 7th inning stretch because they did the video montage of Harry Carey. And then he had a picture after Schwarber hit it and they saw the ball there. So the news helicopters were flying over it this morning. They found it up there this morning. So, God, that was a fun game. Anyway, think about what would you be able to do in your calculator to figure out the maximum height? Yeah, there's a max min calculator. Watch this. Let's get your calculator out and I'll show you how this works. Oops. I'll pull the equation back up, just get this thing started up. The equation is negative 0.0032x squared plus x plus 3. Okay? Now I know you guys all curse these calculators, but as we get better with them, you're going to be all right. Trust me. Right now, your screen might be a little bit different, whatever, but we want to add a graph. So if you hit your home screen, you should come up with an option to hit add a graph. You're going to get some f of x. That's where we're going to type in that equation. Negative 0.0032 x squared plus x plus 3. Okay, and I'm just going to hit enter. Oh, I forgot to put max in there. My bad. Start over. I forgot to put an X in mine. I'm sorry, guys. 0.0032 x squared plus x plus 3. Now it should work. Oh, it's still there. Why is this? It should be straight. Anyway. Oh, it's because my window's all messed up. All right. So here's what we're gonna do. Go to your menu, and we're gonna go to Analyze. And there's that maximum value again. All right.
You're gonna need to change the windows.
Okay. I don't know if this. To change your window like we did with the old one. Remember how you guys changed your windows in the old calculator? This one's just a button to press. Which one do we have to change? We have to change our x maximum and our y maximum, right? So let's just guess as far as Oh, does this do zoom?
You do the zoom out and then you click it a few times.
Okay. Oh, yeah, that's just as easy, isn't it? Okay. Let me go one more so we can. All right. So there's our curve. It's not as clean as what we used to be able to set up. I'm sure we can find the shortcuts to go through it. But what we're going to do is just hit our calculate maximum, which is the same way we did it before. Go back to that menu. Here, instead of it saying calculate, you're going to use the option that says analyze, which is number 6. We want to find the maximum, so we choose number 3. Remember when we did these lower bounds and stuff like that last year? Where you move the cursor over, hit enter, move the cursor back. So this lower bound, last year we called it left-hand bound. You want to set your cursor to be to the left of it. So we're going to move it over. I'm going to hit enter. Upper bound, we're going to hit on the other side. And it's giving me a maximum at, was it 156 and 81.1? So which one of those would be the vertical height? The 81 and change, right? Are you guys getting 81 and change on yours? Somewhere
No,
there?
no. Oh,
It-
wait, no, I got 81.
Okay. It depends on how far you have your zoom and how close. I mean, we're talking, it's an approximation here. So what you're doing is the same stuff we did last year, just with a weirder looking calculator. You're still analyzing the graph as far as how do I find the maximum? Well, I could factor this if I wanted to. I could find zeros. I could do all that kind of junk, but there's no reason. Just press the button. Hey, how are you?
Great, how about you?
I'm doing good. It's a nice sweater.
Thank
A
you.
little early, but it's cool.
Not getting the spirits full though.
And she wears shorts.
Yep.
Nice work. Okay, so idea here is, guys, what is it that you're looking for? It was asking for a maximum height. Well, maximum height looks like it's at 81.1 feet. That's about it. Okay. You're utilizing the tools of the graphing calculator to make it work. It's not as scary as it may seem. Okay. What I want you to do tonight is I gave you guys that second day stuff. Can I still do your short pass? Thanks. The second day stuff here, and it's same section, still 2.1. It's numbers 38 to 52 evens, and then 66 and 68. I do want you to try 78 also. That's not on there, but it mirrors the same idea of that baseball problem we just did. I just want you to try one of them with your calculator to adjust around and play around with it a little bit to see if we can start working on those. Because we'll be working on a lot of that stuff tomorrow. Yeah. All right. You gotta go.
I got